Yesterday I was showing you how to deal with for loops. So we're using for, then you put in some a variable, or what you call the iterative variable. Then you can put in the next word is in, then the iterative data type or something like that. Then you put in your semicolon, then you give your indentation, then you write your codes. So action codes, okay, action codes. So this was what I taught you yesterday for loops. Now while loop is also a bit similar, okay, but I'm going to show you the difference. I'll show you while loop, then I'll show you the difference between while loop and for loop, and when do we use for loops and when do we use while loop, so that you can really get the heck of it. So let's say we want to find a perfect square, okay. So let's say write a computer, let me zoom in. So write a computer program to find a perfect square, okay. So we are going to write a computer program to find a perfect square. So when we say a perfect square, for example, 1 is a perfect square, okay. So 1 squared in Python double asterisk. So 1 squared is what? 1, okay. 2 squared is 4, okay. So not perfect squares, we want to find squares of numbers. Yes, squares of numbers. So 3 squared is 9. Then 4 squared is 16. So given that a user is going to make an input, okay, so the user is going to make an input, okay. So the input is going to be something like let's say if the user inputs something like 50. Now 50 becomes the lower bound. So we want to write a computer program that can the find the nearest, or the nearest perfect, sorry, the nearest square number, greater than the user's input, okay. So find the nearest square number greater than the user's input. So if the user make an input of 50, what is the perfect square number that is greater than 50? The nearest one, the immediate one. So that's the least square number greater than 50. Okay, so let us keep on going. So we have 5 squared. 5 is going to give us what? 25. Then we have 6 squared. 6 squared is going to give us what? 6, 36. Then we have 7 squared. 7 is going to give us a 49. Then we have 8 squared. 8, 61. Okay, so you realize that since the user input 50, then our answer is supposed to be 61. Okay, so 61 is the nearest square number, the nearest least square number given the user's input. So if the user input something like, let's say 10, the nearest number that is greater than 10, which is a square number, is 16. Okay, so all what we know is that when the user gives an input, the nearest square number is going to be greater than the input. Okay, so in case the user inputs something like 16 itself is a square number, but we want what? The nearest square number greater than the user's input. So if the user gives 16, then our answer is supposed to be 25, but we don't know where that nearest square number is going to be. Okay, we don't know where that nearest square number is going to be. So what we are going to do, there are two ways to solve it. Method one is that when a user makes an input, let's say the user made an input of what, 50. Okay, for example, now with method 1, you can find the square root of 50. Okay, let's say 50 raised to the power half, 0.5. So that's the square root of 50. And the square root of 50 is going to be approximately, let me see, let me quickly calculate it here. I'm coming. So, okay, so 50 inside the square root is going to be 7.07. Okay, so let's say 7.07 approximately 7.07. Okay, so once we get this number, we can increase the number to the nearest whole number. So the next whole number is going to be what? 8. The next whole number is going to be 8. Okay, then we can say, what is 8 square? 8 square. 8 square is going to be what? 8, 8, what? 64, not 61. Yes, so the nearest square of 8 is going to be 64. Okay, so that being said, so then it means that and the answer is also what, 64. So the expected answer here, so expected answer was 64. And by using this technique, we find the square root of the number, then we approximate higher, we round it up to the nearest whole number, then we find the square of it. Okay, we find the square of it and we get our answer. This is method 1. But as you can see, this is purely mathematics. Okay, so let us assume that we don't know this math. Okay, and we want to check. Okay, we want to use a while loop to check every single number if it's a square number or not. So let me say method 2, which is less efficient though, but I'm just trying to illustrate the concept of while loops. Okay, okay, so let me say while loops. So for, let me use while loop. So we have 50. The number we are looking for is something greater than 50. We don't know when we are going to get there. But one thing we need to know is that when we find the square root of that number, it shouldn't be, it shouldn't be a decimal. Okay, it should be an integer. Okay, it should never be a decimal. Okay, so we can say that let's say the user's input is called, let me call it num. Okay, and we make it 50. Okay, so given that the user's input is 50, we can say that while number, the square root of what, number, which is 0.5, while the square root of number let me just put something. So while the square root of number, let me say int, when we convert to an integer, is equal to, now when you convert to an integer, it will delete all the decimal places. Okay, so 0.5. So I'm saying that if we round this one down to the nearest whole number, if we round this one down to the nearest whole number, it should be equal to the same thing. Okay, or we could have put round. Okay, so we could have put round. So if you round it to the nearest whole number, sorry, if you round this to the nearest lower, you round it down to the nearest whole number, if it's the same as this, then it means that it's a square number. Okay, so 50 will give us what, 7.07. When you round it down, you get 7, and 7 is not equal to 8. Okay, when you run it down, 7 is not equal to 8. So this will be false, and the loop will keep on going. Okay, so once we have this, So once we hit 64, now the square root of 64 is 8, 8.0, and 8.0 is equal to what? 8. So 8.0 and 8 will be equal, and once they are equal, it means that we found what? A square number. So given this concept, we can simply write our loop. So we can say that we can, while this is false, or like, no, not equal to that. So not equal to means that if the number here, the rounded number here, is not equal to the actual number, then it means we've not found our answer. So number will now be equal to num plus 1. Okay, so number will now be equal to what? Num plus 1. So we increase 50 by 1, and it goes to check again, and we increase 50 by 1, it goes to check, and it keeps on doing that until it finds the answer. When it finds the answer, it will terminate the for loop. Okay, it will terminate the for loop. Then now we can print out our new number, the new number we've found. So let me run this and let's see. So we're expecting 64. Okay, so we get our answer at 64. So this is a while loop. Okay, now as you can see, it looks a bit different from the for loops that we've been using. Now the syntax for a while loop, you say while starting with a small letter, all of them are small. Then after while loop, you state your what? Your condition. Okay, just like if statement, you put a semicolon, then you indent. Okay, then you put your action codes here. Okay, so while loop, condition, then action codes. Okay, so you state your condition. As long as the condition is true, the loop will keep on working unless the condition is false. So this one here, it's a little bit complicated. Okay, so let me take a very simple one and let me express this thing here. So let me comment this one out. So we go, so control KC. So from here, I'm going to say, for example, let's say we want to print out happy birthday until we reach the person's age. Okay, so let's say the person's age is 18. Okay, and we'll start the printing from 1. We'll start the printing from so let's say from 0. We can say that, or let's say the counting, let me call it count, so you get the intuition. So while we are counting, if our count is less than the person's age, then print happy birthday. So okay, so we are going to say happy birthday a certain number of times depending on the person's age. Okay, so then we say that we increase count is equal to count plus 1. Now this code here, okay, this code here can be written in a different form. Let me show you how you could have written differently. You could have said count plus equal to 1. Okay, you could have replaced this with that. So we increase count by 1. So to print happy birthday, then we increase count by 1, happy birthday, until count is equal to age, then it stops. Okay, so when I run this code, realize that we are going to see happy birthday repeated 18 times. So you see, this is the first one, second, and so on and so forth, 18 times. Okay, or if we want, we can count it. So you say count, so that we see the number of times happy birthday has been repeated. So when you run this, it starts from 0. it starts from 0. So 0, okay, 0, 1, 2, 3 up to 17, meaning that there are 18 happy birthdays. Okay, so this is a while loop. So a while loop depends on a condition. A for loop, on the other hand, usually depends on iterations. You are iterating over a variable. So quick you can write. So here with the age we can say input, then we ask the user to enter the age, enter your age. Okay, then once the person enters his or her age, we convert to an integer. Okay, so sorry for the noise. So from here we can see if the person is 5 years old, then we get happy birthday 5 times. Okay, so we can delete this. Then let's say run it again. If the person is let's say 20 years old, then we get happy birthday 20 times. Okay, so somebody, it's not always you can use it for this. For example, I think in the early days we wrote a simple code, okay, where we can let's say you've created an app or a game and you want the person to play a number of times. So for example, let's say we have a game, okay, so we are creating a simple game. Okay, now in this game the user will be given choice. Okay, so it's for children. So the computer will display a number. So the computer will display a number and ask the user, which is supposed to be a child, um, if it's a if it's an even number or odd number. Okay, so then it gives the user some score. So let's say the person's score is, let's say, 0 because we are starting afresh. Then randomly, so let us import random. So it's a random import random, or let's say from random import rand int. I want an integer. Okay, from random import rand int. So I can say that the number, okay, the number is rand int. So between 1 to 100, the computer should randomly pick a number between 1 to 100 because we are dealing with a child. Okay, so pick a number between 1 to 100, random integer between 1 to 100, and print, display on the screen. So we can say answer. So input. So tell the user this. What, or let's say, is it an integer or sorry, is it an even or odd number? Or let's say, what kind of number is it? Then \n means go to the next line and put option 1 even. Okay, then option 2, but next line, option 2 odd. Okay, so when it appears on the screen, it's going to appear like this: option 2 odd, then option 3, let's say option 2 odd, then it chooses. Okay, then \n, so the user will enter 1, 2, or 1 or 2. Okay, once the user enters 1 or 2, we know 1 is even, 2 is odd. Okay, so from here I can say if the number we picked, if this number divided by 2, the remainder is 0, then it is even. I've taught you how to write if statements. Okay, then it is even. So then we say the person's score, we increase the person's score by 1. So I'm using this technique here. Okay, instead of saying score is equal to score plus 1, like for example, saying score is equal to score plus 1, we rather say we can simply write it this way: plus equal to 1. Just increase score by 1. Okay, so this is some new trick I want to show you today. So it's going to increase the person's score by 1. Then we print on the screen. Okay, we print on the screen good. Okay, we print good, then we show the person's score. We say good, then we say, let me say score. Now the person's current score, we show it with what score. That means the person has gotten plus 1. Else we say that what? Else we say not quite right. Okay, not quite right, not quite right. Then we print what? We subtract from the score. So we punish the person by subtracting from the score. So here we say what? Score minus equal to 1. So when you lose, you subtract from your score, not quite right. Then we print the person's score. Okay, so you say score. Now your new score will be printed to you. Then we put score over here. Okay, so I'm just trying to develop a simple game. Okay, so then this program is going to run. So let us run it and see. So when I run it, I get what kind of number is it? Oh, we are not showing the number here. So let's say even. Oh, it was an even number, but I didn't show the number here. So let us go back to our code because we need to show the what kind of number is it. What kind of number is it? Where should I put it? In the beginning or at the end? So in the comment section, what do you think? Where should I put the number? Somebody should say something. What kind of number is it? Should I put the number at the end or in the beginning? Let me say, where should I put the number? In the comment section, somebody should say something. I just want to get your attention in case you are watching. Okay, nobody is really saying something. So let me say, what kind of number is it? So let me put the number here. Now I'm going to insert the number in here. So I put in number. Okay, then you put in F, meaning that you are formatting the string. So F means that this string is going to be formatted, and it allows you to insert external kind of data types into it by putting what curly brackets. So I've told the computer to insert this number into the string here. Without this F, it won't work. Okay, so now let us run our computer program again, and we see that what kind of number is it? 49. So 49, is it even or odd? It is, let's say, even. When we say even, it says not quite right. Our score is -1 because we started with a score of what? 0. Okay, we started with a score of 0. Now before we start the game, maybe the user's score should be showing at the top. So let's say print score. Okay, score, print score, semicolon, then we show the person's score. Okay, so once we run this, so the person's initial score is 0, right? So what kind of number is it? 41. So let's say 41 is an even number. So we say enter, then it says, wait, sorry, it's wrong, not quite right. Then we get a -1 and our score decreases to negative. Now you realize that at the end of every program, I have to start my program again. Okay, so at the end of everything I do, I have to rerun it again. So we can use a while loop to run it. Okay, now if I'm to use a for loop, it's going to run it for a specific number of times. If I'm to use a while loop, it's going to run it until a certain condition is met. Okay, so let me write a while loop here. I want to loop over this part. Okay, even I want to loop the numbers, the random numbers the computer is selecting. Okay, so I want to loop here. So I'll say while maybe the user's answer, okay, while the user's answer is, let's say, equal to, okay, while the user's answer is not equal to 3, okay, while the user's answer is not equal to 3, proceed with this. Okay, so they should keep on doing these. So I've put everything under the while loop. So you select everything, then you press the tab, it will shift it under the while loop. So while the user's answer is not equal to 3, so I say 1 is even, 2 is odd, then let me put another one. 3 is what? Maybe 3 is close. So maybe the person wants to stop the program. Okay, so 3 is close program. Okay, so 3 is close, or maybe end. Let me put end. End will sound more nice to a child. So 3 is end. So to keep on running until the user press end. Okay, so this is a condition that as long as the user's answer is not end, okay, as long as the user's answer is not 3, do not stop the program. So when I run this, I see says traceback error. The name answer is not defined. Did you mean absolute? No. So they are giving me an error because I have to first define the answer here in the beginning. Okay, so then what I have to do is that I have to say, so in here, one, there are two strategies. One, I can say answer is equal to, by default, I can say it's equal to none. Okay, I don't know. So I don't know what the person's choice is going to be. So I can say answer is equal to none. I just need it temporarily here, so my program can run. So it gives me my score is 0. What kind of number is it? 12. Is it even or odd? So it's even. Then my score is now 1 and says what kind of number is it? 80. Is it even or odd? Then we can say it's odd. So 80 is even. Okay. So press 1. Now my score is now 2. What number is 97? Let's say I got it wrong. I said even. It says it decreases my not quite right. It decreases my score by 1. I'm left with 1. Now my current score is this. Now I can keep on going. I can keep on saying this is odd. This is let me just keep on pressing. Okay, so I'm playing the game and it seems I'm losing. So it seems there are more. Okay, so now my current score is what? 3. So I can keep on playing the game until I select 3, which means end the program. So when I select 3, it ends the program, but still it does the deduction, not quite right. It subtracts the score, but at least it ends the program. Okay, so I'm using a while loop to say that keep on running this program, keep on running this software for me until this condition is met, until answer is what? 3. But I realized that before I could use this condition, I had to predefine this variable I needed. Okay, now there's another way of going around this. So I can delete this one, okay, and instead of this, I can say while true. Now, while true means that run this code forever, never stop. If I run this, we'll play and play and play and play, and it will never stop. While true means forever it is true, so run it. Okay, so we'll never stop. Then let us now we would say that then we have to come to our options. So if the user chooses, if number divided by 2 is equal to 0, oh wait, this one is not working quite right. Oh, my software has a problem. Okay, so this is the answer, right? The answer is going to take the user's input, whether it's even or odd. Okay, so no matter what I select, whether it's even or odd. Now, if if the user's answer is even. So if the user's answer is what? Even. Even means 1. And when you divide that number by 2, it's equal to 0. So if the user chose 1 and indeed the number 2 is even, then do this. Then we come to the next option. Else, if the answer the user chose is 2 and the number in question divided by 2 is not equal to 0, then it means it's odd. So the user chose odd, and the number 2 is odd. So we also have to add 1 to it. Okay. But then you realize that this condition will require that we add 1 to the score. So we can also put it up here by using the or. So we can say that this, if this is true, this whole thing up here is true. Or the user chose odd and indeed the number is odd. Let me cut it and paste it here. Let me put some brackets around it just to give you the sense of separation. Okay. I'm coming. I'll deal with this one here. So if the user chose 1, which means even, and the number in question, the remainder is 0, meaning that the number in question is also even, then the score should be added. There should be a score addition. Or if the user chose odd, which is 2, and the number in question is also odd, then score should be added and say good. Okay. Else if any other thing apart from this happens, or else if the opposite of this happens, let me just put else, or let me just say else if the answer the user chose, okay, is not in the list. So if the answer the user chose is not 1, it's also not 2, and it's also not 3, then you print what? Wrong. Let me say print. Let me say wrong output. Or sorry, wrong input. So then it means the user has selected the wrong number. Okay, so in my first game, I didn't really account for that. Okay, so you realize that I'm trying to teach you the programming by using it to solve practical problems, and I hope I'm not confusing people here. Okay, so let me see if everything is going on as expected. So if you have questions, you can put it in the comments. Okay, so let us continue. So I'm just trying to show you how the while loop runs. Okay, so while true, this code will keep on running. And I'm saying that if the user chose even and the number is even, or the user chose odd and the number is odd, add 1 to the score. Else, if the answer the user chose is not inside the options of 1, 2, and 3, just say wrong input. Now, this brings us to the next thing I want to talk about. There are some special keywords, let me call it keywords, used keywords in loops. Okay, special keywords used in loops. There are 3 of them. So far, you've seen pass. Pass means that do not do anything, just move on. So when a computer sees pass, for example, let's say I type here, else I need to write something here, okay? But for now, I'll just say pass because I don't have my codes yet. So pass means just skip, okay? So when the computer gets here, it will just skip. Then we have another one we call break. Break means that stop running the loop, okay? Break means stop running the loop. Then we have the last one, continue. So I'm going to use continue here. So if the answer the user selected is not 1, 2, and 3, tell the user wrong input and what? Continue. Continue means that go back up here to the loop and start the process again. Don't finish whatever you are doing, because the input the user have provided is not within our list. Okay, the input the user have provided is not within our list. If we want, we can bring this one up here. It will be important that you check whether the user's input is within your list before you start using it. So I'll prefer to send this one up, Control X, because we have to check the user's input before we start using it. So I can say that I can make it if. So if the answer the user provided is not 1, 2, or 3, that's not in 1, 2, or 3, not in this list, then forget about it. Just continue. Continue means that go back to the loop and start all over again. Okay. Then we say else if the user said it's even and the number is indeed even, or the user said it's odd and the number is indeed odd, then say good and increase the score by 1. Else what should happen? Pass. Don't do anything. Okay. Now we can also say that now we've done for option 1 and option 2. Okay. Now let us see how we can use this word break. Break means that stop the code. Okay. So let me say stop the loop. So break stops the loop. Let me say stops the loop. Continue restarts the loop. Okay, continue restarts the loop. Then pass just moves on without action, or like move on. Yes, let me say move on. Okay, so we have pass meaning just move on, break meaning stop the loop, continue means restart the loop. So when the computer hits this continue, it restarts the loop. So while true, this one, it picks a random number, print your score, and say input, and say what kind of number is it, blah blah blah. You choose 1. Then it says if the answer the user provided is not 1, 2, or 3, so the user put in any other thing, print what? Wrong input, and continue, meaning restart the loop. So go back to the top and start it again. So the computer keeps on doing. Now remember that I said while true means run the loop forever. Run the loop forever. So when would the code stop? So that's where we use what? Break. So break means stop the loop, terminate it, end it. Let me say end the loop. Let me just say end the loop. Okay. So else if the person's answer it provided is number 3, then instead of saying pass, we will say break. Break. Okay. You break the loop. So if the person's answer is not in the list, say wrong input and continue. If the person's answer is 1 or 2 and corresponds to the number, giving the person a score. If the person chooses 3, it means stop the loop and get out. Then when do we punish the person? Okay, we've not put our punishment, so nothing will happen to the person. So let us say else if the person provided an answer, so our punishment is going to be the opposite of this. Okay, so let me say Control C, Control V. So if the person says it's 1, but then the remainder of the number is not equal to 0, or the person says it's 2, but then the remainder is rather equal to 0, that's the opposite. Okay, so here if the person says it's even, 1 means even, but then the number turns out to be odd because the remainder is not equal to 0, and or the person says it's odd but then it turns out to be even, then instead of printing this, we say what? Control C. We rather say you subtract 1 from the score and say not quite right. Not quite right. Okay, then we say score, then we give the new score. So this is the punishment, sorry, this is the reward. So let me just say reward code. Okay, it's good to give comments. Then there's the punishment code. Then this is the termination code. So termination code. So if the person wants to stop the whole loop, uses the word break. If the person wants to, if the person doesn't choose the correct input, so validation code. So it validates. Validation code. It validates whether the user is choosing 1, 2, or 3. If it is not, it goes back to the loop and starts all over again. So let us run this simple software I've written and see how best it works. So let me run it. So over here we have our current score to be 0. 28, is it even or odd? It's even. So we say, then it says good, your score is now 1. So what kind of number? This one is even. Okay, our score is now 2. Okay, so 93 is odd, so we say 2. Now our score is 26. Now imagine if I put in something, it will say what? Wrong input. It still keeps our score to be 3. Nothing happens to our score, but it changes the number. Okay, it changes the number. So it still acts as even, odd, or so let me say it's odd. So it rewards us with 1. We get 4. Now it's even. 91 is odd, but let me say even. It says not quite right. Then it says the score is what? 3. Score is supposed to be 3. Okay. And when we say, and keeps on running, because we say what? While true. So it will run forever. But when we press 3, it will break. So when we press 3, the whole code breaks. It doesn't continue again. So this is a simple way. Now you could see that the whole screen is repeating. Okay. But I want to clear the screen every time. Let me make my app interesting a little bit. So I can say, I can put here that import, I think, sys. So I would say every time it runs, let me say, now I'm using so I'll say sys dot clear. Is there anything like clear? Oh, I've forgotten. Let me quickly check. Okay. So oh, I'm not finding the results. So sys dot, is this system? No, something clear. I think it's sys dot os. Am I correct? Then since I'm using a Windows, I'll say clear. I think so. I think so. So let me run it and see. Oh, I got an error. I just wanted to do this last trick. So let me check online. So sometimes as programmers, I forgot I used to do this trick a lot of times. So clear, let me say clear terminal in Python using the syslib. Okay. Okay, so sometimes let me see. Oh, so rather import OS, then we have os.system. Okay, so I imported the wrong library. Yes, so I remember it's rather os, sorry, os. So then we rather say os.system. Okay, so os.system clear. So I think this one should work. Clear not recognized as an internal. Okay, so let me use something like this. Oh, so what's the correct way to use? So let me check. So from here we can see that, okay, CLS, not CLR. So you have to keep on practicing your code, lest you forget. CLS, okay. So CLS means clear. So it clears my console. So you realize that now you don't see anything except this. So my score is 1. So 57 is an odd number. So I put 2. Now it clears the console and brings it back. So it just looks like a game for me for now. 86 is even. 14 is even. 48 is even. 13, let me just make a mistake, odd. Then it says what? That's 1, 3. So I lose 1 point. 61 is odd. Then 67 is even. 67, sorry, it's odd. Then even, then odd. I feel like I'm playing a child's game. Then 100, let's say mistakenly I said 100 is odd, so then I lose a score. So it becomes more or less like a game. And when I press 3, it terminates the game for me. And this is my current score, and that is it. So I've shown you how to use a while loop. Okay, this is using a while loop by stating a condition here, or you can say while true or whatever it is. Then you can write in your codes, and here I designed a simple game for a child to deal with even and odd numbers here and there. It breaks if you put in 3, okay, using the break keyword, and here it continues. That means it doesn't proceed with the following code. It restarts the loop if you don't input the correct values. Okay, so for example, if I run this one more time and I don't input the correct value, let me just say I put in something, it doesn't have effect on the code. The only thing it does is keeps on changing the numbers. So this is even, this is 21 is odd, 100 is even, 83 is odd, 14 is what 14 is even, 14 is okay. Okay, so sorry. So that being said, so now putting 3, I terminate my code. Okay. So for those of you who are using MacBook, I think for MacBook it's rather clear. So MacBook, you have to say operating system dot system into bracket clear. Okay. So if you are creating a code, if you are creating a software for this, you don't know whether the person is going to use a MacBook or a Windows. So you have to write an if statement. So if blah 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 else those kind of things, you can write an input statement for that. So that being said, so I think I'm done with this, but now let me show you the difference between if statements, sorry, for loops and while loops. So difference between for loops and while loops. Okay, so with for loop, one thing about for loop is that you need an iterative variable, and you have to iterate over, let's say, a range. Let me say 1 to 100. Okay, let's say I want to add all the numbers 1 to 100. So you realize that you use for loop when you know the range of values you are dealing with, or the number of times you have to deal with a code. For example, when we're talking about factorial, okay, when you say 10 factorial, let me say 10 factorial, it simply means that you are multiplying 10 numbers. That's 1 times 2 times 3 times 4 times 5 times 5 times 6 times 7 times 8 times 9 times 10. Okay, so we know exactly the number of numbers we are multiplying. That is 10 factorial. So we can say for range from 1 to what? 11, because we know range will end 1 before the number. So from 1 to 11, we know exactly what we are dealing with. So all what you have to do is what? Maybe initiate an external counter, or let me say answer. We start from 1. So even since this one is already 1, I can even start here from 2. So then I can say that my new answer, instead of saying answer times I can simply write it as this. Because I'm repeating answer, I can simply write it as this: times equal to I. So multiply answer by I. Okay, then when you keep on doing that, once you are done, print answer for me. Okay, but you can also initiate a break. You can say if maybe I is greater than 5, break means that stop everything you are doing. Okay, so if I is greater than 5, break. So it will only multiply up to 5. So you can use break. But when you use pass, it means don't do anything, just move on. If I is greater than 5, pass, go away. When you use continue, since if I is greater than 5, go back to the loop and continue, or start again. Okay, so if I'm to put this one here, control X, if I'm to put this one after this if statement, control V, you realize that anytime I think it's time, anytime I run this code, if I is greater than 5, that means it will run 1 times 2 times 3 times 4 times 5. Once I becomes 6, if I is greater than 5, it will do what? Continue. Continue means that do not come and do this action. Start all over. Okay? Or maybe let's say if I is equal to 5, let me use something like this. Now let me comment this app out. So control K and C. Okay, control K C. Yes, to comment it out. So let me put my break point. You go behind the numbers, you put in your break points, then you come here, then you run your debugger. So Python debugger. So let's see how it goes. Let me just take some few minutes to clarify the difference between for loops and while loop. Okay, so from here, so for now, let me close this one. These are previous ones we're dealing with. Okay, so from here, when we run this, we have our variable answer is equal to 1. Then our I variable is equal to 2. So if I is equal to 5, continue. Continue means don't do anything, restart the loop. So it's not equal to 5, so it comes to multiply answer by 2 and increase answer to the new number. Okay, so now 2 times 1 is 2, so now answer is now 2. It goes to the for loop and pick the next number, which is 3, and if 3 is equal to 5, which is not, so it doesn't, so it goes away, then goes back. So 3 times the 2 giving us 6, then goes to pick the next number, which is 4, and goes to pick the next number, which is 5. Now the number is 5, so 5 is equal to 5. It will continue. Now let's see how the continue affects the code. When I click on this, it doesn't perform this action. Continue means what? I said continue means restart the loop. So once it hits continue, it goes back up. It didn't perform the multiplication, so this answer wouldn't increase. When I press it, it goes to pick the next number, so the answer still remains as 24. It goes to pick the next number. Now 6 is not equal to 5, so there's no way to even continue. This action will take place. This one takes place, and we get an increase. So it means that by default, we've eliminated 5 from the calculation by saying continue. Now let me use the word break instead. Let me say break. Okay, break. So restart. So when I restart the code, okay, so it starts with the answer to be 1, keeps on multiplying. Now I is 3, keeps on multiplying. Now I is 4, performs the calculation, goes back, now picks the next I, which is 5. Now if 5 is equal to 5, which is true, it will break. Break means it will terminate everything, get out of this loop, to get out of this loop, okay, and come to the print. So now it selects a break because this condition is true, so it's going to break, then get out of the loop. So as I said here, break means what? End the loop. So whatever you are doing, stop the loop and come here. So then print out the answer. We get 24. Okay. Now if we put pass, nothing will happen. Everything will just move on as normal. So sometimes you put pass if you don't know. It's just a placeholder sometimes. Okay. So I think we've run out of time, but I'm trying to demonstrate these keywords. So from here we go. Now I is 5, then we run it, it says pass, nothing happens, it continues as normal. Okay, continues everything as normal. So somebody will ask, why do we have to use pass if nothing happens? Sometimes it's just a placeholder. Maybe you want to write a code here, but not now. But if you remove this one here, it's going to give you an error. So you just put pass for the meantime. Sometimes just put pass to hold it, because after writing an if statement, there should be a condition. But you don't have it now, so just put pass for the meantime. Okay, so that being said, I think so. For a for loop, you should know the range of values you are working with. But for a while loop, while I is less than 10, okay, while let me say answer, while answer is less than, let's say 100, while answer is less than 100, maybe perform some calculations. Do what? Control C V. So answer will start with what? 1. Now let me comment this one out. Control K and C. So when you comment this one out, so while answer is less than 100, for here we can't use an I. It doesn't go to, it doesn't pick any value. Okay. So while answer is less than 1, let me, instead of multiplication, let me use okay, let me use multiplication. So we multiply by 2. So there are multiples of 2, right? So 1 times 2 give us 2. So is 2 less than 100? Yes. So then that 2 times 2 give us 4. Is 4 less than 100? Yes. 4 times 2 give us 8. Is 8 less than 100? So it keeps on doing that until the answer becomes, let me remove the red dot and let me put it here. So I run a loop and we see how while loops also work. Okay, so while loop is usually based on a condition. So that one, usually you don't know the number of times it should work. I don't know the number of times I have to multiply 2 by itself to get closer to 100. I don't know. I can't really tell. Is it 10 times or 5 times? I don't really know. But I know that it should be less than what 100. But I don't know even what 2 times 2 times 2 times 2. Which number of times would you get a certain number that is closer to 100, such that when you multiply by 2 again, it will exceed 100? I don't think you can even tell either. So when we multiply here, you see that the answer changes to 2. Okay, now 2 is less than 100, so it keeps on with the condition 4, 8, 16, 32, 64, 128. So now answer is 128. So 128 is greater than 100, so it will stop because we've exceeded a condition. So use a while loop when you are dealing with conditions, when this code has to run until a certain condition is satisfied. But if this code has to run for a certain number of times, like 11 times or 10 times, you can do with a for loop. So for loops are used for a number of times, taking an action a number of times, while loop are used for taking an action until a certain condition is satisfied. Okay, so take note of the difference. We've come to the end of our class. So if you don't have any questions, I would like to end it now. Bye.